Hello, Chem 2 students. Mr. Keister here with you again. This is the video for Friday, November 20th, 2020, which is our scheduled 65th day of school for the fall semester. Always keep in mind, though, the dates could change for a variety of reasons, but the lessons and the order that those lessons are presented will remain the same regardless. So let's take a look at our do nows and see what our schedule is for today. Today you are going to pick up Unit 5 Review, page 86. We are going to finish up this short mini unit today. Your homework for today was to complete Organic Compounds number 2. That is now due. So if we are here in school, you are to turn that into my desk. Should already be turned in, actually. If you are at home, you need to submit it to me electronically by the time your regularly scheduled class period begins. So make sure it is not late. Of course, you can check your answers either here on the board, if you're at school, if you're at home, on the answer keys page in Canvas. Today, we're going to finish up the short version of Unit 5, which involves the naming and formula writing of organic compounds. Today, we're going to finish the last lesson regarding branched chain alkanes, alkenes, and alkynes. The Organic Compounds number 3 assignment that you picked up yesterday and we didn't get to, we will be doing that for Monday, okay? That will be due on Monday. Also, over the weekend, you are to work on the Unit 5 review, which you picked up today. It will be due by the beginning of class on Tuesday, all right? Tuesday. And I will be collecting it for a grade. There will be no answer key with that one because, again, as I've mentioned before, there will be no exam over this mini unit. So it will count for significantly more points than a regular review would. We've been down that road before, you know the drill on that. And again, I'll remind you that even though we're not having an exam over Unit 5, that the material from this unit is going to show up on the next several exams and most certainly will be on the final. All right, so having said that, let's get to today's lesson. So we're going to look at branched chain hydrocarbons. So you think of branches when you think of a tree, probably. And so what do branches look like on a tree? Well, you've got on the tree, you've got the main trunk going like this, and then you have branches that branch off from that main trunk. Well, this is pretty much the same thing. Where our trunk is our main chain alkane, alkene, or alkyne, and then we could have connecting branches on that main chain. So that's exactly, what it sounds like is exactly what it is. Now, in that branched chain alkene, or alkene, or alkyne, it has had one or more hydrogen atoms in that main chain replaced by what is called an alkyl group. Alkyl group. An alkyl group is a group of atoms that are formed when one hydrogen atom is removed from an alkane molecule. All right, so these are add-ons. They are attached to a carbon atom in an alkane, alkene, or alkyne. They are not standalone molecules. So they're an attachment just like a functional group is that we've been talking about the last several days, like an alcohol, an alcohol group, or a ketone group, or an aldehyde group, whatever. An alkyl group is basically the same type of thing. It is an attachment that we will latch on to the main chain, that main chain being an alkane, an alkene, or an alkyne. So as an example, these are what alkyl groups look like. So methane, of course, is an alkane, a standalone organic molecule. A methyl group has had one of those hydrogens removed. So if you think about it, so here's methane. Well, if we take one of those hydrogens off then, and this carbon has an unshared, an unpaired electron, that is where it's going to attach onto the main chain molecule. And so the shorthand way of writing that is right here. So this becomes CH3, all right? So, and that latches onto the main chain from that C right there. So ethane, of course, is an alkane. An ethyl group has one of those hydrogens removed. So again, if we just, so here's ethane, like so, all right? We take one of those hydrogens off, this becomes what is called an ethyl group, all right? And again, the shorthand way of writing that is like so, all right? CH2CH3. Here's propane, which is a molecule, standalone, and a propyl group has one of those hydrogen removes, and so then again, it would be an attachment. And so that would just add on another CH2, all right? Note that in an a little star there, just like I have already, note that in an alkyl group that the dashes within the group are removed, all right? You notice here I didn't put a dash between that CH2 and that CH3, or in an ethyl group. I did not put a dash between the CH2 and the CH3. This is to so as to not confuse them with the main chain molecule. All right. So in an alkyl group, if it involves multiple carbons, we remove the dashes in between them so that we can tell that it's an alkyl group, that it's an attachment, rather than it's a part of the main chain. Okay. All right. So let's get to how we name them. Advance the screen here. All right, so here we go. So the base name of the alkane or alkene or alkyne, meaning the main chain, is the longest continuous chain of carbon atoms. The longest continuous chain of carbon atoms. We call this the parent chain. All right, now many times the parent chain is a straight line, but it doesn't necessarily have to be. So I'm going to show you some that aren't, and then we're going to work with a lot of them that are. Okay. Now, the prefix identifies the branching alkyl group and indicates by a number the specific carbon atom or atoms where the branching happens. All right. The numbers in the prefix are made as small as possible, just like we've talked about before. It's the same numbering system we've used before, where we have to identify where a functional group is attached, here where an alkyl group attaches. So you can start numbering from either the left or the right, it doesn't matter. But we have to make sure that we're using the lowest number possible. If the same alkyl group is used at two different branches, in other words, if we have a methyl group at carbon 2 and another methyl group at carbon 4, all right, then the prefix di is used along with the correct carbon numbers. The same alkyl group at three different branches, we would use tri, all right? And I'll show you a couple of examples of that. So let's see how we determine the name of a branch chain hydrocarbon from an organic structure, all right? So let me speed this up here. All right, so let's, we're going to start with a basic alkane here, butane, which is CH3, CH2, CH2, CH3. No, shouldn't be any confusion about that. Okay, so now I have a branch here, and this particular alkane is called 2-methylbutane. Now let's see how we get that. All right, so we have to determine first what is the longest continuous chain of carbon atoms. All right, well, let's look. So we can go straight across 1, 2, 3, 4, or right to left 1, 2, 3, 4. That gives us 4 carbons. I could go 1, 2, 3, could go down, or it could 1, 2, 3. That's 3. Well, 4 is greater. I could go 1, 2, 3, 4, or 1, 2, 3, 4. We have 4 again. So we've had, I think that exhausts all the possibilities. So we had 4, 4, and 3. The biggest number is 4. So our parent name is butane. Notice the parent name goes last. All right. We kind of start at the end and work our way back to the front. It's kind of opposite of what we normally might do. Okay, so now we know that our main chain has 4 carbons. Well, let's take a look at it. If I number them left to right, 1, 2, 3, 4, then I have a methyl group at carbon 2. All right, I have a methyl group at carbon 2. If I name them right to left, 1, 2, 3, 4, I have a methyl group on carbon 3. All right, 2 versus 3, 2 wins. Remember the lowest number. So right now I'm looking at a methyl group on carbon 2. Now remember, there was another way to get 4 carbon atoms in a row, and that was 1, 2, 3, 4, or the opposite way. So if this is our parent chain, then here is our methyl group attachment. And if I draw it this way, that is attached to carbon 2. If I do number them the opposite way, 1, 2, 3, 4, it's attached to carbon 3. Again, 2 wins. All right? So whether we name it like that or we have our parent chain straight across, we have a methyl group at carbon 2. And so here's how you write it. 2, you write the number first. That's where the attachment occurs. Put a dash after it. Identify the alkyl group that is the attachment, in this case methyl, and then connect that directly to the parent chain name. So this would be called 2-methyl-butane. All right, 2-methyl-butane. All right, so now let's try some on our own. Now that we figured out how we got that name, let's look at some, figure out if we can figure this out for ourselves here. Okay, so let's see here. Well, a lot of carbons there. Let's see what we got here. So we have, well, I could go 1, 2, 3, 1, 2, 3. That's not very many. I could go 1, 2, 3, 4, 1, 2, 3, 4. I could go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I could go 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. Looks like 5 is the most number of carbons I can get in a row. It's all single bonded, so that means it's an alkane. So that becomes then our parent name then would be pentane. So we'll write that first. Remember, that's the last part of the name, but we're actually going to write it first. All right, so let's see. How did we get 5? Well, we could go 1, 2, 3, then go down 4 and across 5. So there's 5. Looks like I have a methyl group attached to carbon 2, and I have another methyl group attached to carbon 3. All right? If I reverse this and count the other way, 1, 2, 3, 4, 5, then I have a methyl group at carbon 4 and a methyl group at carbon 5. 2 and 3 versus 4 and 5, 2 and 3 wins. All right? Now, there was another way we could get 5, and that would be going up here. So it would be 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. And if that was the parent chain, this is also pentane, I would have, again, a methyl at number 2 and a methyl at number 3. If I go the other way, it would once again be at 3 and 4. So once again, 2 and 3 wins. So we have 2 methyl groups attached to 2 different carbons, carbons 2 and 3. So here's how we write it. We have to list both numbers. So smaller number first. So we have 2, 3. We list them both, put a comma between them. Now the dash. The name of the alkyl group is methyl, but there are 2 methyl groups. So again, we use the prefix di. All right, so this is 2,3 dimethyl pentane. 2,3 dimethyl pentane. All right. Now I want to point something out to you. All right. So this is a branched chain alkane. 2,3 dimethyl pentane. But I want you to look and see how many carbons are there altogether. 1, 2, 3, 4, 5, 6, 7 carbons. How many hydrogens are there together? 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. C7H16. Ring a bell? If that was one long continuous chain, one long continuous alkane, it's all single bonds, that would be called heptane. All right, so if it was a continuous straight chain, C7H16 is pentane. So what does this mean? Well, what it means is 2,3 dimethyl pentane, which is a branched alkane, and heptane, which is a straight line or straight chain alkane, are what? They have the same formula, got the same number of single bonds, same number of C's, same number of H's. They are, what'd you say? Structural isomers. They are structural isomers. 2,3-dimethylpentane and heptane have very similar properties, but not exactly, because the shape and bond angles and so forth, repelling forces based on that shape are a bit different, all right? But they are isomers, okay? Let's go on to the next one. All right, so let's see what we got here. Well, let's see, how many carbons in a row can we get maximum? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, looks like 4 is it, all right? And so our parent name would be butane. Butane. All right, now, so let's see, there was quite a few ways I could get 4. Let's go the straight chain way. I always like the straight ones. A little easier to look at, a little easier to figure out. But it doesn't have to be that way. We'll look at the others too in a minute. So it looks here like if I number left to right, straight across, that I've got 2 methyl groups attached to number 2. If I number them right to left, I have 2 methyl groups attached to number 3. 2 versus 3, 2 wins. All right. Now I could put the 1 up here or down there, and then the other 3 would be there. And if I do that, 1, 2, 3, 4, I have my 2 methyl groups are now still attached to carbon 2. If I go the opposite way, they're attached to carbon 3. And if I had number 1 down here, again, now my 2 methyl groups are up here. They would still be attached to carbon 2. And if I went the other way, they'd be attached to carbon 3. Either way, 2 wins. All right. So we have 2 methyl groups, both of them at carbon 2. We have to write the 2 twice. So it'd be 2, 2. That means we have 2 attachments at number 2. Now, both of those attachments are the same alkyl group, a methyl group. So again, we use the prefix dimethyl butane. Dimethyl butane. All right. Make a little note here on my notes. There we go. Okay. We good on that one? All right. Oh, gosh, we got a big one now. Let's look at that one. Ooh. Crazy looking one. Now, like I said, a lot of branched chain molecules do go in a straight line, and then the branches go up or down. But I want you to see some of these because they can look kind of crazy sometimes. All right, it's like this one. Okay, well, let's see what's the largest number we can get in a row now. Well, let's see. Well, straight across would be 4 or 4. I could go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Looks like 7's the winner, all right? Which means our parent chain name is what? 7. All single bonds, heptane. That would be our parent chain. All right, so let's see. How do we get 7? 1, 2, 3, 4, 5, 6, 7, or the reverse direction. So let's look at that. Well, if I looked at that, I got a methyl group here on number 3. I also have a methyl group here on number 4. If I go the opposite way, 1, 2, 3, 4, I would have a methyl group at 4 and a methyl group at 5. 3 and 4 versus 4 and 5. 3 and 4 wins. And that's it. Those are the only 2 ways we could get 7 carbons in a row. So 3 and 4 wins. So it would be 3, 4, again, a dash after the last number. And then since they're both methyl groups, we could say dimethyl heptane. All right. 3, 4, dimethyl heptane. All right. All right, now let's determine an organic structure of a branched chain hydrocarbon from its name. These are kind of fun. It's like putting together a puzzle, I think. I really enjoyed doing this. So hopefully you will too. So let's look at these here. All right, so here's what you got to do. Now remember, the last part of the name is the parent chain, and that's what we're going to start with. All right, so this is 4-methyl 2-hexyne. Well, that means 2-hexyne is our parent chain. So think about it. Hexyne, that's an alkyne, which means it has a triple bond in it. Well, where's the triple bond? Well, that's what the 2's tell us. The triple bond's after carbon 2. If it's 2-hexyne, that means the triple bond is between carbons 2 and 3. All right. So let's draw hexyne, which is 1, 2, 3, 4, 5, 6 carbons, and the triple bond is at carbon 2, which means it's between 2 and 3. So I'll put a triple bond right there. All right. So there's the parent. Now we're not done yet, of course. Now it says 4-methyl. Okay, so that means we're going to attach a methyl group to carbon 4. Well, remember here we numbered left to right because that's 2-hexyne. So we're going to have to number the same way. Normally, if you start left to right, I mean, that's the way we normally number anyway. So it's kind of convenient to do that on a regular basis. Then it kind of takes some confusion out of it because you know you can number the opposite way. But anyway, a methyl group on carbon 4. So 1, 2, 3, 4. Here's the methyl group. You could have went below too, above or below. They're mirror images of each other. Doesn't really matter. All right. Now, one thing I would want to make sure you understand. I don't want you to draw these in a sloppy way. All right. Now look, the C here in the main chain attaches to the C in the methyl group. All right. Make sure the C's are connected. In other words, I don't want you to draw it like this. All right, you see that where the C is attached to 3 H's? Well, no, it's not attached to 3 H's. The C is attached to the other C. All right? So make sure you show that. All right? No sloppy drawings. I'll count off for that, I promise. So make sure you're aware of that. All right? Okay, well, we've got everything there. Got to finish it though. There's hydrogens in there. So let's see. The first C will take 3. 1, 2, 3, 4. None there. 1, 2, 3, 4. None there. 1 there. 2 there. 3 there. Now we're ready to draw it. All right. So we got CH3 single, C triple, C single, CH with a methyl group attached, single, CH2 single, CH3. And there you have 4-methyl 2-hexyne. Like I said, it's kind of like putting together a puzzle piece by piece. Kind of fun, really. All right, let's do the next one. 3,4-dimethyl 1-heptine. Okay, so our parent chain is heptine, and it's 1-heptine. So what does that mean? Well, it's an alkyne again, so that means it's got a triple bond, and since it's 1-heptine, that triple bond is right after carbon 1. So heptine is 7 carbons. 1, 2, 3, 4, 5, 6, 7. Triple bond right off the bat. All right. Then it says we have 3,4-dimethyl. That means we have a methyl group at carbons 3 and 4. So here's carbon 3. I'll put a methyl group. Here's carbon 4. I'll put a methyl group. Now, I put them on opposite sides. I did that just out of convenience. You could put them both up top, both below. It doesn't really matter. Whatever you prefer. I'll count it right either way. All right. I just usually do it that way if they're right next to each other, so they don't look so crowded in there and when I'm trying to draw. All right. So there they are. And again, make sure the C is attached to the C. Don't be sloppy. All right. Okay, now H's. Well, the first carbon would take one, none there, one there, one there, two, two, three. Octet rule, remember? All right, so what's our final product? Well, we have CH, triple, C, single, CH with a methyl group, single, CH again with a methyl group, single, CH2, single, CH2, single, CH3. And that is 3,4-dimethyl 1-heptine. All right? Last one. Cool. This is a big one. All right. 2-ethyl, 5-methyl, 3-octene. Okay, so our parent chain is octene and it's 3-octene. That's an alkene, meaning it's got a double bond in it. Where's the double bond? Well, carbon 3. All right. So let's draw that. So we got 1, 2, 3, 4, 5, 6, 7, 8. Triple bond at 3, which means it's between 3 and 4. Or sorry, not triple bond, double bond. All right, double bond. So there that is. Okay, now we have an ethyl group at carbon 2. All right, ethyl. Ethyl comes from ethane. All right. Remember ethane, CH3, an ethyl group has one hydrogen removed from that because it's an attachment, CH2, CH3. And again, in an alkyl group, if there's multiple carbons, we don't put dashes between them so that we don't confuse them with that they are a part of the parent chain. So a carbon 2 will put an ethyl group, CH2, CH3, no dash in between there. And then we have a methyl group at carbon 5. So 1, 2, 3, 4, 5. And again, I don't care where you put that, above or below, it really doesn't matter. I got them both above because I can fit them in there without too much difficulty. All right, so let's fill in the hydrogens. First one, 3. Second one, 1. Third one, 1. Fourth one, 1. Fifth one, 1. 6, 2, 7, 2, 8, 3. Octet rule. Done. All right. We're ready to finish. So we've got CH3 single, CH with an ethyl group. And again, make sure you attach C to C on those attachments. No sloppiness. Single, CH, double, CH, single, CH with a methyl group. Single, CH2, single, CH2, single, CH3. Man, is that a thing of beauty or what? Woo! Nice one. All right. Now, one point I would like to make. This is called 2-ethyl, 5-methyl, 3-octene. So this one has 2 different alkyl groups attached to the parent chain. So my question is, why is it called 2-ethyl, 5-methyl rather than 5-methyl, 2-ethyl? What's the difference? Is there a difference? Is there a correct way versus an incorrect way, or could we have done named it the other way around? And the answer to that is there is a correct way and an incorrect way to do this. And so let's talk about that briefly. 2-ethyl, 5-methyl. So why do you think we name it in that order and not the reverse? What do you think? Well, in years past, someone immediately raises their hand usually and says, I know why. It's because the ethyl's attached to 2 and the methyl's attached to 5. Lowest number goes first. And you know what? I would say that is a fabulous answer. Unfortunately, wrong. All right. What else could it be? they said, well, an ethyl group is larger than a methyl group. Probably need to write the bigger one first. That's another good answer. That's not right either. Let's see, what else could it be? Anybody thinking about it? Let's go back to grade school. It's really a simple answer. Ethyl begins with an E and methyl begins with an M. Guess what? It's alphabetical. All right. So the placement of alkyl groups. All right. The placement of alkyl groups in the name is alphabetical. So even if this had been their numbers reversed, if the ethyl was on 5 and the methyl was on 2, we still would have listed the ethyl group first because alphabetically it comes before methyl. Simple as that. Okay? So I think you should now be able to complete organic compounds number 3, the assignment you picked up yesterday that we didn't get to. You can now do that for your homework. That will be due Monday. Remember, you also have a Unit 5 review, which is going to be due on Tuesday. All right, Tuesday, giving you an extra day for that. Again, no test over this mini unit. And so this review is going to count for a whole lot more, and there won't be an answer key available for it either. Okay, so let's see. I think that's all I've got for today. So enjoy your weekend, everyone. And until next time, it's Mr. Keister signing off. Stay safe. Be healthy. Keep working hard and stay focused. Until next time, folks. So long.